Hi, good afternoon, my math students. Welcome to another lessons with me, Sir Sheldamore. So what we're going to learn today is numbers that are in disguise. I require my students to know this first before they will identify the different numbers, if it is rational, integers, natural or counting numbers, whole or real numbers. So most of my students are confused how to identify this kind of numbers because these numbers are indeed in disguise. So for your note-taking purposes, I recommend you to write down wherever I'm going to write here. So the topic that we will learn today is numbers. That's not good, so I'll write it again. So we have here numbers in disguise. So what's the meaning of disguised numbers? Though these numbers are considered rational at first, but when you evaluate it, it could be in a different form of number. So the best example, if I will give you, is 15 over 3. So most of you will say, oh, it's a fraction. So I will say that is already a rational number, but it's not. Because if you evaluate that, that's like 5, 15 divided by 3, which is a natural number or counting numbers. So you will think at first that it is a rational, but it is not. It is in fraction, but you need to evaluate first, then it will be 5 as the new number. So you will identify what is 5 than just 15 over 3. Okay? So another example will be negative 24 over 8, which is equal to negative 3. So you will think at first that negative 24 over 8 is already rational, but it's not. Because if you evaluate negative 24 over 8, that will be equal to negative 3. So therefore, you will not gonna put negative 24 to rational, but into an integer. Okay? So I hope that's making sense. So they're in disguise. So don't get confused right away. You need to evaluate if they could be simplified or not. So another example will be 18 over 9. So which is equals to what? Which is equals to 2. So therefore, 18 over 9 is a counting or natural numbers. We have another 25 over 5, another counting or natural numbers. We have here 42 over 6, another counting or natural numbers. That's going to be 7, and negative 49 over 7, which is equals to what? Negative 7. So this number is not really a natural numbers, but indeed an integer. So negative 49 over 7, if you evaluate that, it will be equal to negative 7, and negative 7 is an integer. I hope that makes sense to you, because once you identify these numbers, you will not confuse yourself, and you will think first that, oh, I need to evaluate first before I can identify if this number should be irrational, it could be natural or counting or in an integer. So we have another set of how to call these numbers in decimals. They're also in disguise, so we need to be careful whenever we look at those decimals. Most of my students struggling with this because they never, or they failed to evaluate their numbers first. So we have another set of example, which is negative 7.08. So most of my students will say, oh, that's irrational, but it is not. because negative 7.0 is also equivalent to negative 7. So you need to be careful with that. So negative 7 is just an integer. So if we have also like 49, oops, like 49, okay, so you will say, oh, it is a decimal, but once you evaluate 49.0 is equals just to 49. So therefore, it is just a counting or natural numbers. So we also have here negative 15.0. It's not a rational. It is what? A integer. It is an integer. So if you evaluate that, that's going to be just negative 15. And negative 15 is just an integer. So I have here another negative 8.0. It's not a rational number because it just has decimal and a 0 after the negative 8. It is actually just an integer because negative 8 and negative 8.0 is just equal. So they try to confuse you so that you will think harder, but you need to be careful whenever you solve your answer. So negative 25.0 is just equivalent to, oops, is just equivalent to an integer because it's just like negative 25. One last example will be negative 100.0. So it is just an integer because it is equal also to negative 100. So hopefully you will, be guided how to identify these numbers because these numbers are really in disguise. So I'm gonna give 10 examples or practice before we're going to move to the next lesson because we need to see first if you really understood this concept. It's going to be hard for you to put this or identify these numbers in real number system chart if you're still confused. So let's see if you can evaluate all of these. Evaluate following numbers. Okay, so you need to evaluate first before we can solve or identify these numbers. So we have number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, okay. So we're going to answer now. I'll give you a minute or so to copy or guess give the answers of these numbers. So go ahead, I'll give you a minute. So I have 30 more seconds left. I hope you're copying it. If not, at least you're giving me the answers for this one. All right, time's up. I hope you have the chance to answer all of these. So we're now gonna check your work. So if you have a red pen or any marker that you can use for checking your work, put down your pencil and let's see if you got this correct. So negative 8.0 is equivalent to what? Negative 8 also. Which is called as what? An integer. Okay, an integer. 24 over 6 is equals to what? 4, which is what? Counting or what? Or a natural number. So it's natural. Negative 15.0 is equals also to what? Negative 15, so it's an integer. Okay, I hope you're getting it. Negative 25 over 5 is just negative 5, so therefore it's an integer, right? So if you're putting negative 8, 4, negative 15, negative 5, give yourself a check for each. I'm just putting all the words integers counting so that it stick on your head. What kind of number are these? So negative 18 over 9 is also equivalent to negative 2. So therefore it's an integer. Okay. 10.0 is also equivalent to 10. So it's a counting or what? Say counting or natural. Negative 14 over 7 is also equals to negative 2. So that's an integer. And negative 26.0 is equivalent to negative 26 also. Therefore, it's also an integer. Okay? So, if you got this all correct, you are ready to move to the real number system and you will have more practice about it. Okay? So, let's see.